Welcome, welcome. My name is Jeffrey Palermo, and I'm the CTO and chairman of ClearMeasure. And I'm going to talk today about the AI software factory pattern, not as a coding tool, but as an executive level architectural pattern for overseeing and optimizing software delivery. And really, this is about orchestrating how software moves through an organization so we can systematically increase throughput through AI adoption while keeping quality high. Um, we're going to be sharing some links in the chat window, and you can also ask questions there. You can ask questions in the Q&A window, and I've got a lot to get through, but any questions, throw in there, and we'll make sure to answer those. Our our goal is to empower you and your software teams to deliver world-class results. The mission of ClearMeasure is to empower software delivery. And so not only do we build software for our clients and turn around troubled projects and challenging modernizations and migrations, but we also advise and guide. We have lots of clients that we do, fractional advice for, and just a sounding board, keep on the rails. We'll come in and um, we'll do audits or inspections on existing software projects and help keep them going well. So this demo that I'm going to show you today is is two parts. The first part is uh, how we believe you should be thinking about AI automation in the software process, but overall, how to measure the benefit that we are seeing from adopting AI-driven development in the software delivery process. Because I think everybody who's paying attention has seen the stories of the CFO questioning the amount of money being spent on AI tool usage and then questioning, okay, well, where's the return on investment? Are we actually moving any faster? It still seems like we're missing deadlines and we're missing dates and it seems like we're not actually delivering more for the business. And that's the important part is as we invest more in AI, we need to make sure that we actually achieve the promise, and that is faster throughput, faster software delivery for our businesses. So that's how I want you to think about this. All right. Okay. So, um, every organization wants more software delivered faster. The demand for change is increasing. The team size, it's mostly fixed in most organizations. You staff a team and then you figure out how much we can do in that team. And software delivery throughput has always lagged the business need for software that automates certain business processes. And the promises that we're hearing around AI adoption continues to uh, not be realized by a lot of companies. Everyone's trying to figure out how to get it done. And and so the problem here is not the lack of ideas or demand for custom software. It's really that software delivery has become the constraint and for most organizations continues to be the constraint where the business side is asking, when is it going to be done yet? And the solution of artificial intelligence is not just a drop-in product. It's not just a click the easy button. It's really a different way of thinking. Okay. Um, so the current approaches, whether even more than a year ago, before the AI coding tooling really took off for multiple vendors, is about is how we think about speed. And speed, it really fails if you make that the goal. You can't optimize directly for throughput. So for example, AI, it doesn't do anything automatically. Uh, and furthermore, when you use it, well, guess what? There are defects that are introduced by regular people, by software engineers, and also introduced by AI coding tools. So that those defects, it consumes our capacity. And then stability incidents in production, they consume the team's capacity because somebody has to fix them. And so any of these types of rework, it steals the time of the team from software delivery. And most organizations, they want to go faster. That alone doesn't work. Throughput is not something you can directly command. It's what remains after defects and instability stop stealing your team's capacity. And AI can't automatically do anything just by itself, much less give perfect work consistently all the time. And so I want to talk about how we think about AI, and we are using the heck out of all of the AI tools, and we are very bullish and moving forward. And there's right ways to get a good investment out of it, and there's mistakes. I mean, one of the big mistakes is just to uh, turn it loose on your code base with some broad instructions and just let it run for hours at a time. I mean that will reliably screw up any kind of software patterns you might have had in the code base. And in order to get test suites to pass, it'll remove assert statements and delete tests. Kind of notorious for doing that. Pretty boneheaded things. And so any powerful piece of machinery has to be operated by a very competent equipment operator. Think of AI as equipment. It has to be operated by a competent software engineer. And all of the large language models put inside these AI coding harnesses, amazing tools. And they are really good at answering questions and working on tasks. But what they can't do, that only the software engineer can do, what they cannot do is ask the right questions. These AI tools are great at answering questions and doing tasks, but there is no capacity for the wisdom or intuition or experience to know the appropriate questions to ask. What candidate architectures are available here? How should I choose between them? Those are questions that we ask. And now, to get the answers and options to those questions, yeah, the AI tooling is great. But the software engineer knows through experience and discernment and wisdom the right questions to actually ask. So that's a quick aside. All right. So I want to focus on quality and stability here. We want throughput. We want increasing speed. Quality and stability are not nice to haves in this era of AI driven development. They are prerequisites. If defects or production incidents consume the time of our team, then there's no capacity left for throughput, no matter how much automation we add. Uh, so if we do an AI adoption in an unengineered way, then that can just really make delivering defects into production happen much more quickly than we already are, and we certainly do not want that. Okay, so I want to look back on some of the uh, textbooks of the past that everything currently is building on. And we have the theory of constraints that was introduced by Eliyahu Goldratt in the book The Goal. This book is a mainstay in so many executive MBA programs, and later books have kind of built on the theory of constraints. But then we have systems thinking and feedback loops. That's been a big topic. We've had the quality management movement from W. Edwards Deming, and then we had the Toyota production system, which introduced flow and waste elimination. There's a lot of textbooks that have come along that introduced or shed light on the dynamics of the type of process that we're working here when it comes to flow-based systems where you have a lot of raw materials, and every station of work kind of does a little bit of work to improve the state of those raw materials into a finished good. And software engineering, and custom software delivery is certainly that type of process. So the dynamics of what we're working with don't change in this AI-driven development world. These are some of the more modern books, and all of these books have some or all of the older four books in their bibliographies. So these newer books, they refer to the older books. And so um, if you were not aware of or haven't read any of the books that I've shown on the screen, then by all means, I encourage you to do so. All right, let's introduce the AI software factory. And again, this is a pattern. Okay, I'm going to show you some code, and it's certainly some tooling that we use in Clear Measure, but it's not this implementation that has any particular magic. This is a pattern. This is a way of thinking of implementing AI and orchestrating it so that you have visibility into what it's doing under the covers. And the AI software factory, I posit is an orchestration pattern for software executives, for people who are running and overseeing software teams. And we have lots of orchestration patterns that are out there. Continuous integration is a build orchestration pattern. The automated deployments, the DevOps pipelines, those are release orchestration patterns. Scrum sprints is a team delivery orchestration pattern. And the AI software factory is an end-to-end delivery orchestration pattern for visibility into the whole with lots of patterns within it. And so we already accept that there are lots of orchestration patterns. And so think about it as the topmost level. And by the way, I don't even care if you call it AI software factory. The concepts are what's important here. You need an overall orchestration pattern that gives you visibility into everything that's going on. So as you adopt AI tools and put them in the mix and integrate them, you have a way so that you can see that it's actually giving you the benefit. All right. So an AI software factory is not a single tool. It's not just AI coding. It is a system that orchestrates people and processes and automation. And this is critical. The AI software factory is about building a system where automation does the repetitive work and engineers focus on engineering. All right. I'm going to say that again. Software engineers need to focus on engineering. These are things that don't have an obvious solution and require some wisdom. But then we have other work that is kind of simple. It's not hard, doesn't actually require any engineering, doesn't actually require any creativity. It's just work that needs to get done. We delegate that to the computer, like we always have. And we delegate that to AI. Okay. So I've made some analogies in the past, continuous integration, etc. We've had some changes in our industry, some movements from a process perspective in our industry. We've had the project management body of knowledge back in the 1990s, and largely the whole industry moved in the 2000s, moved to a different way of thinking under the Manifesto for Agile Software Development. And then starting in 2010, we had the DevOps adoption. And of course, cloud technologies were available there. And so we started treating servers like chickens instead of like pets. We no longer name our servers. We just give them, codes and number them. And when one of them gets sick, we just replace it. Um, and then cloud adoption, where all server and runtime infrastructure is largely fungible and flexible, as opposed to spending lots and lots of money up front in setting up our own data centers. And now we have the AI adoption. So this is one of the big transformations, one of the big adoptions. And with every one of these changes in our industry, we've had to figure out how to think about it so that we can so that of all of the ideas being presented out there, we can safely ignore 80 to 90% of them and really latch on to the 10 to 20% of the ideas that have staying power. That sounds kind of weird, doesn't it? But if you think about it, for those of you who lived through the agile transformation starting in 2001 and 2002, there are so many ideas being put out there. How many patterns, techniques, um, ceremonies, how many that were talked about then have the staying power that we're still doing them? How many ideas were being talked about early in the DevOps transformation that have staying power that we're still doing, and how many just fell off the wayside? Same thing with cloud, and it's going to be no different with this AI adoption. Again, we're only 1 year into materially into the AI adoption for AI driven development. And so you have to expect that 80, that 80/20 rule, that 80% of the ideas being presented now for AI driven development are not going to stand the test of time and are going to go by the wayside. So you have to have discernment into what is the 20% that is anchored on reality and is going to have the staying power so that 10 years from now it still holds true. Okay. Now, not a single one of us has a crystal ball and can pick exactly what those are, but you have to expect that to be the case and look out for that. All right. So let's jump into our first demo. And I'm gonna pull over a few things. So let's see here. Let me get the right screen. Here we go. All right, interactive demo, not just screenshots. We have a sample application that we use for training. It's called boot camp work orders, and we'll put we'll put the link to that in the chat. But you can go and grab this code. It's just a sample application. Latest version of .NET, mix of technologies, has a pretty good README file. You can pull down the code. It has a lot of patterns that are demonstrated. We use it in our training classes, and it's just a simple work order management system, and it's kind of in the theme of First Church of Springfield. For any of you who have watched The Simpsons. And so we have a lot of this doesn't have any kind of security. It's just meant for demonstrating some coding techniques. So I'm just going to pick somebody to log in with. And where is my Timothy Lovejoy? There's a lot of users here. One of the enhancements will be to alphabetize this. But all right, and so we have and probably some CSS improvements on the left-hand side. We have work orders that are assigned to me. I just logged in with groundskeeper Willie, and I have some work orders that are assigned, and I can go through here and I can begin the work order, and it'll change the status, and whatnot. Okay, so it's just a forms over data little application, and I am going to go to my uh, dashboard here. By the way, I have a little sample that's running in Visual Studio. It literally is just my AI software factory implementation. And we have some code that integrates with Jira, with GitHub projects, with Azure DevOps. And so just so you know, I'm just running this straight from Visual Studio. And by the way, all of our clients have full access to this as we kind of implement things. So if you'd like to become a client, yeah, all it takes is 1 billable minute to become a client, and then you just kind of get all this stuff. But that's one we don't publish that as open source because we're constantly evolving it. But this is our dashboard, and let me just simulate something. We have a Kanban board, and I've totally cleared it out. So here's our Kanban board in GitHub projects, and it has nothing on it, but we have conceptual definition, UX design, technical design, and I'm going to I'm going to just create some demo uh, items that are going to start popping up in the conceptual definition. While that is happening, share. Okay. While that's happening, takes just a minute. We are going to um, we are going to look at a health check for this particular application. And so let me go. Oh yeah, you can see them starting to pop up. We're going to go here and we have a health check endpoint. And let's see. It is health check detailed. All right, all of you have this for your applications. you have a number, and this is just using the .NET Health Check API or library, and we have all of these health checks, and they're all healthy. All right. But if I come over to my dashboard and I can just hose the memory of one of the modules in the application, and if I come back over here and refresh, then we can see, look, this one is unhealthy. The memory is corrupted, restart the process. And us have some application out there that, you know what, once a month or every now and then we have to restart some type of process. It's not deterministic enough for us to really figure out how did that happen, and we don't know why, and we can't reproduce it. And by the way, it's so easy and fast just to restart a process that it lingers and it just happens. Okay, every piece of complex system has some process where you know what something's weird, and so we just know, oh, restart that process. Okay, well, we just did that, and so on our Kanban board, this is one of the low-hanging fruit scenarios for AI implementations, and you notice that just moved over. So this ticket is brand new, and we opened it up and look at this production incident, unhealthy components detected. It ran the health check and it logged all of this, and it created automatically a production incident for us. And so anytime we have in production are paying something that didn't work right, we can create production incidents out of that. That's not rocket science. But what we do with the production incident, well, this is just one scenario for AI integration that is pretty easy to implement. And so you can see that our AI software factory matched Cursor as a tool. And by the way, nothing magic about Cursor versus Claude, Codex. All of the AI coding tools have APIs, easy to integrate with, no drama. And so the progress has been journaled, and a agent session was created. There's a link to it, and then it was resolved. It was pretty darn fast. And what we did was we restart the process, and then the health check is happy again, and the work is complete. And we kind of journal what happened, and then we have the AI agent watching this queue, and it got finished, and so then we move it over to done. Okay, and so I'm going to click on this cursor session, and so we go over to our cursor dashboard. For any of you that don't use cursor on a regular basis, this is just one of the cloud agents. And we can see that there's a prompt that we sent in there with all the information about it. And because this is something that happens frequently, we have how to resolve it in the knowledge base. And so this agent can look in the knowledge base and can do the work. And then we can call back and we can say, okay, we can verify that we are healthy. And then we can do a label on our project tracking board and basically finish the session. And that ended up being super fast. Okay. And just I'll show you in the dashboard of Cursor. Let's see the usage. Okay, pretty much every one of these prompts. Well, it's not gonna update in real time. Oh, maybe it does. Maybe it does. Filter by cloud agents. I was hoping it might show up, but these are plenty of runs. These are plenty of runs from the last time, and you can see that prompt used about somewhere in this many 100,000 to 130,000 tokens, and so you can see how much these types of prompts use. They're not writing any code. They're just looking in a knowledge base, analyzing something, and calling a tool or calling an API. And so you can have that kind of usage. And Composer 2. By the way, you don't have to have a powerful model for this type of thing. So that is one example of just automation. All right, let me go back over to here, and we have quite a few of these ready to go. Let's pick, let's see, make the login button, add hide navigation button. Let's pick that one. And what I'm going to do is I'm going to make this a real work item, and I'm going to mark it as ready to go, mark it for the AI software factory. and um, I'm going to kind of let it go, and we can see that the labels have changed at the same time. Okay, and add, yeah. So it is starting. And if we watch this particular one, we can see that it's being picked up automatically by our orchestration. And more of these AI tools are starting to do this automatically, where you can configure the tooling to watch a particular column on your board and just automatically do things, automatically pick it up and process it if it has a particular tag or label. And so in this case, we have it being picked up. We have our cursor session automatically starting to work on it. And so you can see it's currently working on it. And then it's journaling with comments all of the way through. So we'll let that go for a bit. And I'm going to come and I'm going to hit this helper button. We're going to label the rest of the issues just so that they can start moving. I've kind of held them back in this first column, but now I hit that button, which is going to kind of auto approve all of the rest of these issues to start being worked on. Okay, so you can see that they're kind of moving over, and so that's going to be going. At the same time, I can set the app to unhealthy again, and while this is going, we should be able to see a production issue with the health check be analyzed. And look, our production incident just popped up there because we realized that we can create the production incident, but at the same time, it is something that looks like uh, a repeatable thing in our knowledge base, and it looks like it's compatible with an AI tool resolution. And so that's going to get worked on. Okay. Let's go back here and add. This is the work item that we um, kind of started in the first place. And notice that more information around user experience design was just added to the work item. Notice that I was in the UX design column, and now we have added more user experience design. Now, I mentioned earlier that we want software engineers working on the tough problems, and we want the computer, the AI tools, to work on the easy problems. Well, I gave I gave this amount for a concept. Add a hamburger navigation button top left, and then we'll toggle. And this isn't even complete sentences. But if you gave this task to anybody on the software team, you can just read it for yourself. This is one of the easiest things that you can do. I mean, it might not need any kind of code other than some CSS and some markup work in the application. Even without seeing the code, this doesn't look scary. It's not like it needs some architectural decisions or whatnot. So, um, we want to, for these things that are super easy, yes, anybody on the team has the skills to do this. But if it doesn't matter who on the team does it, if it's that easy, why not just give it to an AI agent in an unattended fashion? Okay. And so if we're going to give it to an AI agent in an unattended fashion, then we need the AI tooling to go through the same process that we would. Not a different process, but the same process. And so we see development in the middle of our board. This is where the code happens. And the columns to the left of the development column are design columns. By their very nature, they are columns where we are figuring out what the right thing to do is. And the columns to the right of the development column are verification and testing columns. They are making sure that what we changed in the code base was the right thing to change and that everything is good. And so if I zoom out so you can see the full board, even though you can't read the text, you can see we have a mirrored relationship. A properly structured work tracking board of any project is going to have a mirrored structure. You're going to have a column in the middle, which is where the code, where the software actually gets changed. And to the left of that column, you're going to have a series of stations of work, a series of statuses, each with a column that represents figuring out some aspect of what needs to change. And so you see, we have user experience design, which is questioning how should a person use this feature, use this change. And then technical design, technically, how are we going to make that happen? And then test design, okay, when we make the change, by what manner are we going to make sure that it was actually complete and correct? Okay. And then we have development, which is actually making a code branch, making some changes, doing a pull request, merging that in. And then functional testing is, does it actually function locally and in a first line deployed environment? All these tests, which should be automated tests, do they continue to work? Did we break anything else functionally? Do I have a stable piece of software? And then UX testing. We need to look at it with our eyeballs and say, well, we wanted it to work in a certain way. Does it work in a certain way? Are we happy to give it to our customers? And then the release queue is kind of a verification of holistically, we have a new version of the software. Are we ready to actually send it to production, send it to our customers? And every project is going to have, slightly different columns on their work tracking board, but it's very important that you have a symmetrical design, an intentional symmetrical design. You don't, every one of these work tracking systems kind of gives you a default board that is not started, in progress, done, or backlog, development, completed. They give you three columns, and that is woefully inadequate. So you need to make sure that you have your development column, whatever column you're actually making branches and making code changes and all that. And to the left, think about what the different stages are necessary for you to make decisions in what and how should be changed. And then afterwards, however many different categories of design decisions was appropriate for you, make sure that you have a testing and verification status that verifies that those design decisions were well and correctly implemented. All right, so that's that. We've seen things go across the board. Let's peek back into this work item, add navigation and hide button. Let me actually did it move? Let me refresh my board. Let me open this up. Okay, so we had the agent actually look in the code and craft some user experience design. Basically, it looked in the code and figured out where to put things. Then in the technical design, it added some more design guidance that really could be just harvested from the existing system, and called out implementation tasks. And all this was done by the Composer 2.5 model in Cursor. Again, doesn't matter what type of tool, and calling out the tasks. And there it is, pattern. And these came from Agents MD and Copilot instructions and different documentation. And so we are enriching the work item, and then of course test design. We have integration tests, unit tests, acceptance tests, end-to-end tests. We are effectively creating a plan, a multi-stage plan that becomes the prompt for the implementation. And we have our checklist. Okay. So now all of this represents the plan. One of the best practices that's starting to emerge with these AI tools is you do a plan stage and then you do the implement. Well, this process here is effectively automating the plan stage step by step and inspecting the code. All right, so we'll jump out of there. So that's the first demo. Okay, let's go ahead and come back to the slides. Fantastic. Okay. All right. I think I answered a few questions that came in while we were there. And one more question just came in that I didn't work in interactively. Here's a question. At what point in the Kanban board do pull requests get completed? Are they completed before the item is moved out of the development column, or only once the functional and UI testing is done? That doesn't matter. That's a matter of personal preference. If you, and I think that you would make decisions. If you were a team of two, you'd probably just lump it in and you would and do it in line, or two or three people, you'd do it probably in development. But I imagine if you have a team of 10, you would probably break out an additional column just for code review, or you might lump it in with the functional testing and do the functional testing on the branch before you actually merge the pull request. But that's something for your own judgment and wisdom. I cannot tell you for every project, always do it this way. What I can stress is how to think about it, the principles. And the principle that matters is you have a column in the middle where the system is actually being changed according to the design decisions that are made ahead of it. And then once you have changed the system, then you have columns after that to answer the question, what I just did, is it good? What I just did, should I promote it down the line? Okay. So that's how to think about it, and you'll design the right columns for your board. But good question. Okay, let's keep moving on. Okay, so there are three capabilities that matter in the AI software factory pattern. You need clarity, you need end-to-end visibility about what's going on, because I mean, end-to-end visibility, we need this even without AI. Even before AI, it's been a challenge to know who's doing what and how things are going. Well, now we're introducing these automated agents, not just interactively where I'm using Claude or Cursor interactively, because that almost doesn't matter, because if I am making the commit, then I am operating the AI tool. And so my name is on everything and I'm doing it. But in production, if you have a back-end batch job, there's no user running the back-end batch job. Instead, whoever is operating production, whoever is maintaining and observing production and making sure that it happens, that group is the operator of the batch job, not an interactive user. Okay. So if I'm making code changes and I'm using Claude to help me, well, then I am the direct operator, and every commit is going to be in my name for sure. But I'm introducing AI tooling to run kind of like a batch job. It's running in an unattended fashion, and it's just automatic. And so the operator of that is whoever has the DevOps engineering responsibility on your team, because we are enhancing our DevOps automation. We are enhancing our DevOps environment and graduating to what you might call an AI DevOps environment, where we don't just have automated builds and automated testing suites and automated deployments that spring into action, but now we have automated AI agents that spring into action when work of a certain type, when work that is tagged a certain way drops on the board. Okay. So it's that type of thing. Whoever is the operator of your automated deployments and your automated builds, well, guess what? Now we have a lot more things that are happening in an automated fashion powered by these AI tools. And so we need clarity. We need end-to-end visibility about what's going on. And then we need the ability to change and improve the workflow, which is fueled by having clarity. And then we need the ability to forecast our rate of bugs, our rate of production instance, and our rate of throughput. Okay. Most teams that get to any size only see fragments of this overall process. For instance, product management may focus on the front end of the process. Development teams sit in the middle, and then ops and customer support might focus on the live site and supporting the customers. The AI software factory approach treats software delivery as a single system with multiple stations of work. Each station of work has a named status with a certain type of work that has to be done in order to move it forward. And when we find that we can't move it forward because we missed something, then the work moves backwards one column. And so this Kanban board, it's a great pattern and it stood the test of time, but the work tracking, it has to be comprehensive. Okay. So regular tooling, you might ask the question, why visibility isn't just automatic? We have these great work tracking systems. Well, if we can't see it, we can't management and can't manage it. And most of these working tracking systems don't have bottleneck identification. They don't have root cause analysis. They don't have meaningful automation decisions. They're just like these automated Kanban boards. They're not smart and they don't have reports. Yeah, they might have a burn down chart from the Scrum days, but they don't give you actual insight. And executives would not run a company, would not run the budgets and the finance of a company without actual complete financial statements or weekly cash flow statements and budgeting. And running software delivery without that visibility is the same mistake. But because none of the tool does this automatically, then we have to put it in place intentionally, okay, and be able to forecast into the future. So let me do the second demo. All right, so if we pop open here, I'm going to open up the scorecard. And did it open here? Okay, great. So I'm going to change to week. And we just did some work. I'm going to actually clear out. I have a reset button on the back. Let me just clear out the data. And actually, what I'm going to do is I am going to run a different project. Bear with me a second, because I have it connected to a real project that, close this. I'm going to change it to show work cloud. This is a real project that has run between 2020 and 2022. I'm going to hit Control F5 and it's going to spin up. Let me see, it's starting up. And it's going to start up our, let's see. Oh, I need to punch in one key. So let me do that off to the side real quick. The key expired, so hold on, bear with me. Let me just do this off of my second monitor. Bear with me 1 second, and I think it is back up. All right, running. There we go. So let me open this guy up, and we have data that I need to clear out from what we just did with the bootcamp project. Okay, we have a scorecard. And uh, I'm going to do a custom range and just go back in time to 2020 to 2022. And I'm going to harvest this information. And what it's doing, it's just going to the Azure DevOps board. In this case, it's not GitHub. It's an Azure DevOps board. It's just going to the APIs and it's pulling down just the title and the work item numbers and then the status transitions, which is the revisions. And so you can see that we over the course of those years, this project, we partnered with a client and this was for um, county fairs that couldn't meet in person, so that they couldn't do their junior livestock auctions. All the 4-H kids and FFA kids selling their animal, and so we extended their software system to mimic an online virtual auction, which with an embedded video of a live auctioneer and them thanking sponsors and basically have an interactive real-time auction, not like eBay where it's a passive auction where you just come and you bid and you go away, but actual real time. So these are all the work items from there, and so I'm going to change this to month. All right, so you can see the data. And by the way, this project did not track production incidents in Azure DevOps, so just that section is 0. But what we can see is we can see month over month and even week over week. We can see how much new work went through the system and how much throughput. And by the way, if I say, well, wait a minute, and there were only 4 work items that were delivered here, we can click in and we can see exactly what work items there were. If I click on here, it goes directly to Azure Boards. and we can dive into it. So it's kind of a smart dashboard. But what's really important is to know on average over the last over the last number of roll-up periods, what was our mean time to delivery? If product management asked us for something, how long would it take? And it would take. Let's see if I do over the last 100 weeks. Uh, it was, you asked for something in 6 weeks, it could be done. Now I know these numbers are skewed a little bit, but at a certain time, this project started having defects. And you can see, oh, 10 defects. What were they? And things like, oh, the sort order, and oh, we have some errors in the weight of the animal, things like that. All right. So it's important to have this and be able to drill down what makes up this number, but to have the number itself. Okay. So if I go to the month and I can see that all these numbers. Um, if I go down to if I go down to the anomalies, well, what about rework hotspots? Well, there are some items that moved forward and backwards and forward and backwards and forward and backwards multiple times before getting to done. These represent a lot of waste. And most work tracking systems, they just don't give you any kind of insight. So you need to have this clarity. All right. You need to have the ability also to forecast forward. So let me clear this out again. And I actually have a simulator. And if I come in here and I want to simulate, let's say 30 days, 30 days, I'm going to start this simulator of some history. And let me refresh this. Okay. So I'm going to go week by week, and I'm going to simulate 30 days, and we can see the third week, and then the fourth week will pop up, and and we can see our mean time to delivery or throughput is 11 per week. Mean time to delivery is right at 1 week, a little over 1 week or 1.5 weeks. Okay. Now, if we were to implement artificial intelligence, if we were to implement automated testing, then we would say, you know what, the number of defects escaped, let's improve that. However, we're going to improve it. We're going to improve it. Production issues per week, we're going to improve that. And then we're going to do some AI automation on simple work items. Let's just say that, of the simple work items, not complex ones, of the simple ones, we can get some leverage just on the testing side, a little bit less. All right. And then let's forecast into the future. Forecast, start that. What we can see is we go from 1.5 mean time to delivery weeks and 11 items per week. Well, already we can see the mean time to delivery going down because we have reduced the number of defects, reduced the number of production incidents, and for the simple items, we're introducing AI automation. And we can see as our simulation does another 30 days, we've more than doubled our throughput as a team, as an organization, and our mean time to delivery has gone down. And we can see that in our quality and stability numbers. But quality and stability, if the number of stability issues and defects escape were reliably zero, like absolutely perfect, then 100% of the team's capacity is going to go to delivering new features. Okay. So quality and stability, these numbers only matter at the bottom when you're not happy with the throughput numbers. But you need to have visibility when you're overseeing a software team. You have to have this visibility so that you can know that if you make a process change, if you introduce AI in a particular manner, you expect you're investing, you're spending money on those AI tools. You expect to have a return on that investment. Okay. So that's the one way. Now, this is an HTML dashboard and whatnot. This is a piece of software, but it's not complicated. Let me bring over just an Microsoft Excel equivalent. All right. So here's a scorecard. Here's that ShowWorks Cloud. Um, here's that ShowWorks Cloud version. We can see going back to 2020. It's the same thing. It's just numbers, okay? And a column for every week. And it's just actually column, this is the month view, column for every month. And you need to know what your items delivered were in a given month or week, whatever period time slice, and how many mean time to delivery, how long it's going to take, and then defects and production incidents. Again, this project didn't track production incidents. And so uh, this is just an Excel add-in, and we can literally put in the project in Azure DevOps and the team and the project and the board name, what work item types we actually used, if it was a bug, what tag we used, how we did it, if we have any columns that changed over time, the beginning date, the end date, what period, whether it be week, day, month. Put in a personal access token for connecting, read-only personal access token for connecting to your project, and then you hit build scorecard, and it pulls down all the work items right into Excel and builds your scorecard. So it's not hard to do this, and and if any of you want to become even a small advisory client, we'll get this hooked up for you. And in the overview, it gives you this, it gives you the view of, okay, what's been our mean time to delivery over time, and what's been our defects, and how long does it take us to resolve issues, and how many defects actually escaped, and how many resolved, and whatnot. And then this pie chart, it's really interesting. Over the last year of the project, what was our percent defects or production issues? Very few production issues. And all time for the entire project, what's been our percent waste? Because defects and production incidents, those are absolutely waste. And so if you see the pie chart as your total capacity, you can see the slice of the pie that is absolute waste. And you know what? For when we come in to some troubled projects, this pie chart has very little blue on it, because those teams are constantly fighting fires with defects that have escaped, constantly fighting fires with production incidents that are escalated to the software engineering team. And in that type of process, introducing AI automation does not fix that. You have to get clarity, and you have to leverage AI to solve your quality problems first. Then you'll start going faster, and leverage AI to solve your production instability issues first. Then you'll go faster. Okay, that's important. All right, let's close up here. So I talked about implementing AI automation for the easy things, the things that don't require engineering, but merely require some programming. All right. So, but first of all, you want clarity. You want to model every stage of work. You want to establish a software delivery scorecard, and then you want to monitor your quality and stability trends. Okay. And this will help you identify the bottlenecks, and and um, and then figure out how to implement AI in a good way. All right, I think I answered a lot of questions as I was going through that. Um, I'll leave you with this. Start your AI software factory pattern with the easy button. All right, do the easy things. Step one, get clarity with your measurement. Okay. Then step two, pick the easiest thing that your team spends any time on, and put AI automation in that place to prove out your hypothesis that that super brain dead easy task could be done automatically without a person spending any time on it. That's your low hanging fruit. And once you have proven out that hypothesis, then you can go on to the next thing. Okay. All right. So what is ClearMeasure's role in all this? Our role is to guide you through your adoption journey. As an industry, we've gone through heavy project management process with the PMBOK to Agile, then to DevOps and cloud, and now we have the AI transformation. And all of these transformations have been a different way to think, and a different way uh, to figure out how to better deliver world-class results. So um, at ClearMeasure, we'd love to help you build a safe and scalable and continuously improving AI-enabled delivery system. So So I'll leave you with a QR code. Of course, you can coordinate it in chat as well. But let's schedule an AI strategy session, and I'd love to get to know your software team and your organization and empower your project to deliver absolute world-class results. But thank you for the insightful questions that some of you put through. I appreciate it, and we'll leave this up for a few minutes. And I have Kaylee helping me in the chat, and we can coordinate follow-up appointments. And thanks so much, and God bless.